Welcome to the Exponent Rules Extra Practice video. In this video, we are going to talk about the 6 main exponent rules, and your job for today will be to finish the practice portion by the end of class. The intention is that you finish this in class today. Since there is 50 minutes and this video will only take 10 to 15, you may use each other, your notes, but not a computer, not your phone, not the internet. And make sure that if you're using somebody else, you work together so that you actually understand what's going on, because our test for this unit is coming up quickly next week. All right, these 6 exponent rules are product, quotient, power, negative, zero, and fractional. Let's dive into the product rule first. In the product rule, you will notice that these 2 expressions are being multiplied together. That is how you identify this rule. We are going to do 2 things here. We are going to add our exponents, because if I have x to the 3rd times x to the 5th, that is like taking 3 x's and then 5 more x's and multiplying them all together, which means I have a total of 8 x's. Now, you do not have to write all of your x's out like that. In fact, I'm hoping that you can use the shortcut there. But notice how I added together the 2 exponents on x, so they have to be on the same letter. Then I would do the same thing for y. Now, when I do the y, you'll notice that the y on the right side does not have an exponent. All variables have a default exponent of 1. So that would be 2 plus 1, which is 3. Then I have this extra 9 and 4 out front with a multiplication dot in between. Those are not exponents, those are just regular numbers. So we are going to multiply our coefficients, or regular numbers. So in this case, 9 times 4 would be 36, and that's it. Multiply your coefficients, add your exponents, and you're good to go on that one. The next rule is the quotient rule. You will notice on this one that you see a fraction bar. That is how you identify the quotient rule. Now for this one, I'm going to separate this problem into 3 parts: my x's, my y's, and my numbers in front. For the numbers in front, that is just a fraction, meaning I'm doing 30 divided by 2. So I'm going to divide my coefficients. 30 divided by 2 would be 15. Then I'm going to do my x's, then my y's. Remember that this x on the bottom has a power of 1. What's happening here is I basically have 6 x's on top and 1 x on the bottom. And that x cancels out one of the x's from the top, leaving me with 5. The shortcut here is that you subtract your exponents. You can also just write a minus sign if you would rather. Okay, you do not have to write all your x's out just like the one before that. For the y's, the one difference here is that 3 minus 7 is going to be negative 4. There are more y's on the bottom than there are on the top. In fact, there are 4 more y's on the bottom. So that's going to make y to the 4th on the bottom, which is our negative exponent rule, just getting to it a little ahead of time. So if your answer is negative, put it on the bottom and make it positive, which is the rule we're going to write on the negative here in just a second. All right. Power rule. The power rule is where we're sort of going to distribute this 4 to all the other exponents and to the number in front. And when we are doing that, we are doing, for example, x cubed 4 times. If I write 3 x's 4 times, how many x's will I have? Well, 3 times 4 would be 12. So on this one, we are multiplying our exponents. Now, that is only my exponent. So 4 times negative 5 would be negative 20. 4 times 3 would be 12. And make sure you write the base, x and y, on both of those. Then I have this extra number out here. That 3 has a power of 1 right now, so I need to do 3 to the power of 4, which means I'm just going to call this power your coefficients using this button, the caret symbol, in your calculator, which means I need to do 3 to the power of 4. Let me pull up my calculator. 3 exponent 4 is 81. Then my last step is this y has a negative, so I'm going to move it to the bottom and make it positive. So anytime you have a negative exponent, it bumps to the bottom to become positive. That's it. That's all you have to do differently. Which takes us to the actual negative exponent rule. And on the negative exponent rule, what's going to happen here is I'm multiplying these, so I'm going to use the product rule. 2 times 5 is 10. And then for my x's, 5 plus negative 8 is going to be negative 3. And for my y's, 3 plus 6 is 9. When you get that negative exponent, leave everything else on top and move just the one with the negative to the bottom. And it becomes positive when you move it. So our rule down here is going to be reciprocate anything with a negative exponent and make it positive. That second part is really important because you can't have any negative exponents in your answer. Next rule, the 0 exponent rule. Anything to the power of 0 equals 1. Because everything in multiplication starts at the number 1. It doesn't start at 0 because anything times 0 would be 0. So for example, x to the first power is just 1x. But there's technically a 1 out there. So if I take that 1x away and I have 0 x's, I still have that 1 left. Okay, so that's why it's 1. Now when you do that, this part becomes 1. Because only that has the power of 0. So this would be 13x to the power of 7. On the second one though, that 0 applies to this whole thing. So the whole thing has a power of 0, so the whole thing equals 1. Pay attention to the parentheses because only the part being taken to the 0 power cancels. It doesn't always cancel the whole thing if there's not parentheses. Last rule, fractional exponents. The denominator of the fraction, so the bottom part, becomes the root. So for example, 9 to the power of 3 over 2, 2 is the little number that goes outside the root symbol or the radical. And the numerator stays with the number, so 9 cubed. Now I'm actually going to solve this. When you're going to solve it, we want to make the number smaller first, so we're going to do the square root of 9. What number times itself equals 9? 3. And then you would keep the power of 3, and you would do 3 to the power of 3 in a calculator, or 3 times 3 times 3. 3 times 3 is 9, times 3 again would be 27. Okay, those are your 6 exponent rules. As you work through the bottom problems, look for which one of those you're using. Some of them are going to be negative, product, quotient, power, and then if you get a fractional one, go back to this example.